Okay, we can start. Good morning and good afternoon, everyone. Welcome to this week's Meet the Ravello PMs meeting. My name is Simon Law. I'm one of the outbound product managers for Ravello Cloud Service. I manage the Ravello Lab Service program for SCs. I'm always on the lookout for how SCs and other organizations within Oracle are using Ravello, whether they've built any interesting applications or blueprints that they would like to share within the SE community. So if you have any applications or any Ravello tips and tricks that you would like to share with the SEs, or likewise, if you have any topics, Ravello topics that you would like us to cover, just let me know. Today, our guest speaker is Doug Gallarda. Doug is a Master Principal Solution Architect with the Oracle Communications Global Business Unit. Today, he's going to talk about sorting out mails, I guess, from the screenshot I see. I'll just hand you over to Doug and let you introduce your session, Doug.
Sounds great, Simon. Thank you very much for inviting me to join. I've been enjoying these sessions so far, and hopefully I'll be able to contribute to the conversation. So my goal today is to show another Oracle application deployed in a Ravello cloud environment. But I'm going to do it differently in that we're going to focus on how OpenStack adds value to a cloud environment and how we can do OpenStack-like stuff in Ravello. So here's the agenda, and I have a lot of stuff to cover, so I'm going to talk quickly and leave some time for Q&A at the end. But it should be an interesting session. But if you fall asleep halfway through, I want to make sure that you have one takeaway, and that is to remember this: stale versus fresh. Now, the previous sessions we've had on this call have really focused on taking existing VMs from a VirtualBox environment or a VMware workstation running on your laptop and lifting and shifting that to Ravello. The problem when you do that is the virtualization environment at Ravello is a little bit different than what you saw on your laptop, and the OS is not expecting to be moved to a different place. So as we've seen firsthand on many of these calls, you get a lot of issues that come up, such as devices getting renamed, network cards not set up correctly, and you spend a lot of time debugging those device and virtualization issues. The other thing is that a lot of the things that you did on premise, you really should do differently when you deploy an application in a cloud environment. So what we're going to focus on instead is not importing an existing VM, but building a new VM that is cloud native. And there's some significant advantages to doing that. One is that normally in a virtualized environment, through software, you're emulating hardware devices like an Intel network interface card or an Adaptec SCSI storage controller. And emulating hardware and software is always going to be slower. Well, in a cloud environment, there's optimized device drivers that bypass emulation and talk directly to the cloud platform, giving you a lot faster performance, less latency. The other thing is that cloud native VMs have some secret sauce, some magic built in that allows your VM to talk to the cloud platform and the cloud platform to come in and do things inside your VM to automate, common maintenance tasks and to give you a lot more flexibility than you would have if everything is locked inside a single VM. An example of that is elastic resource scalability, to be able to grow and shrink your deployment by cloning VMs on demand and removing VMs from your application as needed. So we're going to get into this today. Hopefully it will be a good session. And again, hold on tight because we're going to jump right into it. So let's spend some time, first of all, talking about the on-premise Oracle application. Now, I'm going to spend very little time on this. I do not want to give you a product pitch on an application that you don't get comped on. But let me tell you this. What we're talking about is a product that we call the Oracle Communications Unified Communication Suite, offered by the Oracle Communications Global Business Unit. We call it UCS because that's a lot more syllables than we like to say. But you may never have heard of this product, but stay tuned because Oracle's plan is to replace Beehive with what you're looking at right here. It has messaging, it has calendaring, it has address book, It has instant messaging and presence, and it also has audio and video calling through WebRTC. So we've been doing this for a very long time. We have almost 1 billion seats deployed worldwide. Big names like Apple. If you have an iOS device on iCloud, all the iCloud accounts for people that own iPhones are hosted on UCS. Folks like Cablevision and Verizon Wireless, they use us in the service provider space. We have very big enterprises like Federal Express that use us, and then very high security situations like the FBI and the Department of Homeland Security on this platform as well. So it's a very closely guarded secret at Oracle. You've never heard of it before, and with our stellar marketing, most of our customers haven't either, but we've been successful in spite of that. So when you deploy UCS, it looks like this. This is a traditional 3-tier application with a data layer where the databases are, where the customer data is stored. And then we have a web tier, or what we call an access layer, because you can use more than just a web browser to access this data in the middle. And then there's a load balancer that distributes load across all these different boxes as well. So what we're going to do today, instead of trying to touch on all the components of UCS, we're going to zoom into email. And email is a very good fit for kind of showing an environment in Ravello and demoing how data is sent back and forth. So in this diagram, you're going to see that people send email to each other using a protocol called SMTP. So we're going to actually be sending and receiving some SMTP-based email today. That's how stuff gets into our message store. And then we use protocols like IMAP and POP, or a webmail browser to pull things out of the message store where we read. So this is what we're going to do today. It should be pretty exciting. So I'm going to jump right into it. So before we get started, Ravello takes a little bit to get things kind of spun up. So I'm going to build a UCS environment right in front of you in a couple mouse clicks. So hopefully everything will go fantastic. So if you saw, we have the data tier and we have the web tier in Ravello, and I'm going to go ahead and build out UCS. So we're going to have a message store where email is stored. We're going to have an access tier, and this is what talks IMAP and webmail to customers. But I want to be elastic, so I'm going to add some more servers. Here's another one. There we are, and there they are. You'll notice if you drag multiple copies of a VM on your canvas, names are automatically changed. So we went from store to store 1. If I would drop another one, it'd be store 2, store 3, and what have you. So here's our UCS environment, point and click, drag and drop, and we're going to go. So while these virtual machines boot and we stand up our application, I'm going to go ahead and jump back to the presentation and let you know what we did. So before we do that, let's go ahead and introduce the concept of OpenStack and what OpenStack does as a cloud controller. So OpenStack looks like this. You have your application on top, you have your servers or your virtualized servers on the bottom, and then there's this layer of abstraction between the two known as OpenStack. And the big thing that you need to keep in mind is that this is more than just virtualizing hardware. It's an orchestration and an automation layer. So control over the compute resources, the networking components, and the storage are now out of your control, and they're provided to you through the cloud platform. And then you have a pretty little dashboard that allows you to control this and to manage your resources across your application. So when you talk OpenStack, there's a lot of buzzwords and terminology that's used, and I'm going to show you a little bit of it. First is the compute engine. So Nova is the OpenStack component that controls where VMs are launched across data centers and availability domains. Neutron is how you control networking. Everything is not defined by physical network switches and cables. Everything is defined virtually through software, a very important concept. Cinder is how you allocate storage like disk drives to your virtual machines. Glance is a repository where you keep track of virtual machine images and cloud images. And then Horizon is the dashboard. Now in Ravello provides all of these things. They don't use the same terms, but all those same components are there. So with Ravello, we can basically generate virtual machines that run in Ravello, and then you can easily move those to an OpenStack environment, and they're going to run the same way. The nice thing about Ravello is that all of these components in OpenStack are pretty complex, and you need to know what you're doing, where Ravello hides the complexity of the same type of environment and makes it very easy for you to take advantage of it. Now, there's a difference with the cloud, and a lot of folks don't get this, is that when you run a virtual machine or an application in the cloud, you need to relinquish control over a lot of the things that you had ownership of when you ran virtual machines in your own environment on a hypervisor. So you need to let your virtual machine, you need to let your cloud platform take control of those items, because if you don't, you're going to conflict with it and you're going to have problems. So things like networking, before you would have to set up IP addresses and host names, you would have to manage your own firewalls and DNS. In a cloud environment, the cloud platform takes care of that for you, and you need to let it do that. That's where you take advantage of the platform itself. Other things like OS configuration, being able to manage disks, change the size of your boot disk to make it bigger when you run out of room, updating your software in your OS, managing user accounts and SSH keys. All of those things are done in the platform. You do it once, and then you can have multiple virtual machines that the cloud can manage for you, so you don't have to do it manually. Very interesting concept. Now, to do this, you need some special cloud enablement software installed on your virtual machine. Now, we're all familiar with this, because to get the best performance out of a VM running on our laptop, we had to install some special software like VMware Tools or VirtualBox Guest Editions. In a cloud-based environment, we do the same thing, and that's called cloud-init. The difference between cloud-init and the VMware and VirtualBox tools is that it's more than just device drivers. There's device drivers there as well, but the cloud-init framework is where the orchestration and the automation comes in. This is how the cloud platform can get access to your virtual machine and change things, like dynamically change your host name or your IP address, so you don't have to go in there and muck with things once you've already deployed an application. The Ravello Python SDK is the other direction. I can have a virtual machine that can reach out to the cloud platform and programmatically change things about your Ravello application. So that gives you a lot of power. You're not stuck with having to do things with the Ravello dashboard. You can automate those steps as well. So that's the connection between the cloud and your VMs. And if you don't have these pieces in place, you're not really taking advantage of the OpenStack or the cloud-based platform that you're running on. So let's talk about how you build one of these cloud-native VMs with all the secret sauce. So the good thing is that a lot of the work has already been done for you. On eDelivery, the Oracle Software Delivery Cloud now, there's already pre-built cloud images that run in OpenStack environments and in Ravello. So when you go into eDelivery, just search for OpenStack, and you're going to see two things in addition to the other stuff that's there. One is an Oracle 7 virtual machine image for OpenStack. It's for both Oracle Enterprise Linux 7 and Oracle Enterprise Linux 6. So when you download this, and in my case, I downloaded Oracle Linux 7.3, you're going to get a special file. It's not an exported VM. It's what's called a cloud image. The cloud image is bare. You're not going to see the history of people typing commands before you. And it's a building block you're going to use to generate cloud-native virtual machines. So when you download that zip file, you're going to have a file inside it called a QCOW image. QCOW stands for QMU copy on write. And I'm not going to go into the details, but suffice to say, we're going to take that file and we're going to upload it into your Ravello library using the Ravello VM import tool. This is the same tool you use to upload exported virtual machines from VirtualBox and other places. But in this case, we're uploading a cloud image instead. So once that cloud image is in your library, you're going to generate a new virtual machine based on what's called an empty cloud image. So if you scroll down in your list of VMs, you'll see one called empty cloud image, and you're going to drag and drop that onto your canvas. And then all you need to do is go in and replace the boot drive that comes with it with a boot drive based on that cloud image that you uploaded to your environment. So that's where this Oracle Linux 7.3.qcal file comes in. The nice thing with virtual machines in a cloud environment is I'm free to change the disk size at will, and it will dynamically change its size, bigger and smaller, based on what you specify in the Ravello dashboard. The other thing that's different when you use cloud images is that in the general tab of your virtual machine, there's a section called cloud-init configuration that you may have ignored from until now, but hopefully today you're going to learn enough where you can take advantage of this in your own applications. So the two big things that you need to do here is, number one, provide a key pair that you use for SSH authentication. So key pair is something that you specify in the Ravello dashboard, and then you download a private key to your local PC, and that's what's used for SSH authentication. There are no longer any usernames and passwords in your virtual machines, which makes your systems that much secure. The second section down here is called the user data script, and this is where all of the magic as far as automation and orchestration go. So let's go ahead and talk about what that is. Cloud-init automates virtual machine configuration using something called user data scripts. And user data scripts are used at 3 levels in your configuration. Number one is Ravello uses this framework to pass information to your virtual machine that it can take advantage of. For example, the network IP addresses and host names you defined in the dashboard, the SSH keys that you defined in the dashboard are all provided to your virtual machine automatically through this interface. The other thing that we'll do on your Linux VM is it will create a JSON file within a directory called etc Ravello on your OS that provides information about the Ravello application, the application name, the public host name that's been defined. This is stuff that you can use in your application to kind of figure out what's going on and where you've been deployed within a cloud-based environment. Once Ravello is done, the Linux OS takes over, where it will take that SSH key and it will create a user account, in this case, cloud-user, and use a SSH key as the authentication credential for you to gain access. It will also do things like change the host name and IP addresses based on what it got from Ravello as well. Now, that little blank in the dashboard is where you come in. You're able to create your own user data script with your own customizations and override things that have been done by Linux or by Ravello to make it specific to what you're trying to accomplish with your application. So here's an example of something that you would cut and paste into that field in the dashboard. This is what they call a cloud config-based file, and it's in something called YAML format. And that's yet another markup language, or depending on who you talk to, it means YAML ain't markup language. But it's a way that you can pass parameters to your virtual machine. Number one here is time zone. The cloud image that we just showed that was uploaded into your library by default is in the Eastern time zone. I live in Austin, Texas, so I want to change that to Central time zone. And this is the way you do that. You don't have to go in and mess with configuration files or even boot your virtual machine to make these changes. Other examples are packages. The cloud image has a minimal set of packages installed for the operating system, but I bet you that your application is going to need more. And here's examples of where you add those packages to your configuration. The nice thing is that once you set it up in this way, you can download newer versions of virtual cloud images from eDelivery and apply these changes programmatically. So you don't have to go in and mess around in the command prompt in these virtual machines once they've already been booted. And what's nice is I can generate multiple copies of the same virtual machine, and they don't conflict with each other. They can run side by side independently. So let's talk about some differences and some issues you need to deal with Oracle Linux versus other flavors of Linux. Number one is becoming root. Normally, we will create a username and password for root and use that to provide access to the root account. Now, in this world, the cloud-user account is the only one you can actually log into with SSH. Once you've done that, though, the cloud machinery has given that account access to become root. And to do that, you just type sudo -i, and then you get a root level, a command prompt with all the root environment already established, like paths and environment variables and that kind of thing. So that's one thing you need to do differently than what you've done in the past. These next two bullets are workarounds to bugs or unique things that you need to deal with in a cloud-based environment. The first is a system identification. So if you look at Oracle Linux, all it is Red Hat Linux with someone doing a cut and paste, a search and replace, changing all the Red Hats to Oracles. So you can see an example here. This is what it was before, and this is what Oracle changed it to, so it looks like it's an Oracle product. That's great, but there's certain applications, such as the cloud enablement software, that do make decisions based on the name that is in these files. So it's searching not for Oracle, but for Red Hat. So in our case, when it sees Oracle, it says, well, that's not Red Hat, and it drops out of the decision tree. We need to fix this where the contents of SC system release are the same thing as this Red Hat release file. So what I do is in this little configuration, I put a copy command, copy and dash force the overwrite Red Hat release on top of system release, and then everything works. So if you try this cloud image, make sure you put that in there or things will not work. Now, a couple things to keep in mind is that these are commands that you run as part of the first boot, and they're only run on the first boot. There's commands here, and there's commands down here. The difference between the two is that the boot command section is executed very early in the first boot process. So a lot of things aren't done yet, but you want to make some of these changes early on, and this is your opportunity to do that. Now, down here is a section of commands that are run very late in the boot process, and I'm going to get to why there's a difference between the two here coming up. Another issue you're going to have to deal with your virtual machines running in a cloud-based environment is random number generation. So a lot of our products, especially ones that are based on Java or WebLogic, need to generate encryption keys for doing things like TLS or SSL. To do that, they use a random number generator to generate random numbers to seed the encryption key. The problem with the default random number generator that comes with Oracle Enterprise Linux is that to generate that first bit of random data, it listens to your microphone or it looks at mouse movement. People don't always move the mouse at the same way at the same time, so it's genuinely random information. Our problem, though, is when you're running Linux in a cloud, there's no mice attached to that system. There's no microphone attached to that system. So what you'll see is that the random number generator and the installation of your Oracle software product will hang, waiting for the mouse to move. But as we all know, there are no mice in the cloud. So what I do to work around that is I add a new random number generator, rng-tools, and then once that's done, I run a command that replaces the default random number generator with this new one. When I install software from that point on, everything works fine because I'm not waiting for the mouse to move. The reason why I have this command down on the bottom versus having that RNGD command up top is these commands are executed before the package is added. So of course it's going to fail because I can't run something that has not been installed yet. So that's why I wait till the end to run configure that component. Another thing I'll leave you with, and then we'll move on, is at the bottom is something I like to put in my cloud images, and that is a quick update. So yum, if I take this verb up here, is to upgrade everything in my system to the latest release. But that takes some time, and the first boot would take a lot longer because it's downloading all these new components. If I have an image I'm happy with, and I only want to apply critical security patches, I do this instead. So I say yum update, the -y means to answer yes to the prompt. And since there's no keyboard on your first boot, there's no one to answer yes for you, so this is very important. I say do an update, but only do the critical security patches. All right. So the last thing I'm going to talk about is how to install the Ravello Python SDK. So to install Python modules, you need something called pip. And pip is not in the default repositories for Oracle Linux. So we need to add a new repository to your set, and that's called EPO, which is Extra Packages for Enterprise Linux. the RPM command above does that. Then I just do a yum install python-pip, and then it's ready to go. The first thing I'll do is I'll update pip to the latest release by doing that upgrade command. And now I'm ready to type what I wanted to do along and install the Ravello SDK. Having that software available gives you a lot of tools to reach out and talk to and control the cloud platform your VM is running on. Some other things you need to keep in mind when you're running in the cloud-based environment. Since you have a minimal install you're starting with, you need to add packages that you may be missing. So what you'll normally see is you'll run a command and you'll get error messages. I'm missing this file, I'm missing this library. The way to figure out what packages you need to add is a command called yum provides. Yum provides, and then whatever you saw in that error message, and it'll tell you the package you need to install to give you that file. Another thing is a lot of Oracle software products expect to be able to create windows on your desktop. So you'll see a lot of people do things like VNC and other type of things to give you a graphical user interface. You really don't want to do that in a cloud-based environment because you're not always connected to that desktop. And you really don't want a desktop because that's consuming CPU cycles that you don't have very much of in a cloud-based environment. So what you can do through SSH is you can forward that those X Windows UIs to your laptop, tunneling through your SSH client. So that's how you can do it without having to bother with VNC and use up memory in your virtual machine. This other thing is host naming or fully qualified domain names is what this means. Is normally you would have a domain name like oracle.com. In the cloud-based environment, everything is internal to the cloud and not exposed to the real world. So you'll see this domain name that's given to you by default, and that's called local domain. So when you install software and ask for things, make sure you have that local domain appended to it, and then things work. You may have some software that expects to have an IP address that's always the same. Well, in the cloud environment, your IP address always changes based on when you deploy your application, so you can't depend upon a static IP all the time. So localhost is a good static IP address to use for those cases. The other thing is that SE host is something we use in a lot of our POCs for naming. With Ravello automatically configures DNS, and all the entries go in there automatically, so you don't have to worry about it. So instead of putting things in SE host, leverage DNS because Ravello will always keep it up to date. All right. So now we're going to talk about, now that we've built our cloud VM, we're going to talk about how you deploy an application in a cloud-friendly manner. And here's some things to keep in mind. The first is that the cloud is in control. So before, we would always set up static IP addresses. And in a cloud-based environment, and especially in Ravello, what Ravello give you an IP address dynamically using DHCP. That's something that we don't like to do traditionally, but now is we need to start doing that, and so get used to it. It's not bad, and it's something that once you get used to doing things in a dynamic way, you're going to wonder why you did things statically in the past. So the good thing about Ravello, though, is this internal IP address you get is going to stay the same for the life of your Ravello application. So if you do need static IP addresses for certain things, you can leverage that 10.0.0.x address that you're given. The other thing is that the cloud owns the firewall. Normally, you would have to open up ports and IP tables on your local virtual machine. And if in the cloud does that for you. So if you do have IP tables enabled, sometimes it's easier just to disable it or to at least open up all the ports and let Ravello or the cloud firewall control access for you. The other thing to keep in mind, I'm going to show this when we go back to the dashboard, is that you only know your internal 10.x address. But if you need external access, the cloud is going to provide that access for you by giving you a public IP, and it's going to use NAT or port forwarding to allow internal systems to get access to your VM. And this is a very powerful concept in that you can turn ports on and off at will, even when your virtual machine is running, and you don't have to go through an Oracle security review and go through a lot of headache if you want to get the environment up and running and be able to play with things. And then the last thing here is the cloud is elastic. By making IP addressing and host names dynamic in your virtual machines, I can quickly spawn multiple instances of that virtual machine that don't conflict with each other, and you can shrink and grow that number of instances dynamically based on your load. And this is very important. Normally, when I deployed my email application, I would need to size it for the peak load. So if my customer was TurboTax or H&R Block, they get hammered before April 15th, but afterwards, things get a whole lot quieter. So why have hardware resources allocated for your peak April 15th load on April 16th? So elasticity helps you to grow and shrink on demand, so you only allocate the resources you need. All right, so let's go back over to the dashboard and look, everything is running. So I'm going to show you a couple things here. Number one is that I have these message stores that are available, and I've spawned it, and now I have a DNS name and an IP address that have been defined. And all of these components have their own internal addresses and internal DNS as well. So how do I gain access to it? Here are all the externally exposed services. So if I want to do an SSH connection, all I have to do is cut and paste this host name, go to my SSH client, and create a new session. Here it is. Enter, paste the host name, and here I go. Now, you're going to see this quite a bit. When keys for SSH connections are stored based on IP address. In a cloud-based environment, this IP address is always going to change, so get used to having to accept new keys on a regular basis. So I say accept, and boom, I am now logged into this VM. I didn't have to mess with any usernames and passwords, and I can make these logins over and over again to multiple VMs. Makes it very easy to gain access. If I want root access, there you go. So I am now have virtual machines that were quickly brought up and running without having to do a lot of stuff within the OS itself. And through that cloud user framework, it's been very easy to configure those systems automatically across multiple machines. So let's try going ahead and connecting to some of these systems. So I'm going to take a shell command prompt on my local system. I'm running a Mac, and I'm going to make a connection. So we'll go telnet, that host name I cut and pasted, and I'm going to connect to the POP port. So I've now connected to store1.local domain, and I'm able to interact with it. So I can log in and do other things. I'm not going to bore you with those details. So I have a fully deployed application just by dragging and dropping. So let's go ahead and be bold, and we're going to put this environment into production and actually run real life internet email, and I'm going to have you play with it as well. So how do we do that? We have all these funky host names and different things, and those change every time you deploy a VM. So you really can't count on using these to access these systems. So let's do some shortcuts. This is what you need to keep in mind. So number one is that the host name that your VM has been assigned is, as far as it's concerned, is in this case otd.local domain. But the host name or fully qualified domain name that your systems or your customer systems will use to access it is this whole long drawn out thing. And again, when you deploy a virtual machine to keep everything unique, you're going to have these randomly generated keys to make everything globally unique. But that's okay, because once you've deployed a VM, as long as you don't delete it from your canvas, that host name will stay consistent, but the IP address associated with it will always change based on when you bring up your virtual machine and boot it up. But that's okay as well, because what we're going to do is, based on the knowledge that that host name is consistent, is we're going to take DNS and map a friendly URL or host name and attach it to that Ravello host name instead. So if I do a lookup on www.sun1.org, I'm going to make that an alias to this long drawn out Ravello host name. So whenever someone does a connection to that host to sun1.org, it's going to look up whatever the public IP address happens to be at that point in time and make the connection. I do this once, and from this point, it's always going to work because the host name is consistent, even though the IP addresses are not. So let's talk about ways to provide access to a cloud-based environment, leveraging load balancing and failover. So if I go back to my desktop, my dashboard, I can directly access these systems independently, and I showed you how I did that before. But what you do in production, of course, is that you're going to close all these off so they can't be connected to directly, and you're going to use a load balancer to access it instead. So I just happen to have Oracle Traffic Director running here. And here's a configuration, and there you are. So let me refresh my screen since these things are up. What I've done is I've configured Oracle Traffic Director to make connections to multiple servers to host content for the web, and the same thing to provide access to mail protocols like SMTP and POP. And I can add and remove servers from my environment, and when they're added, Oracle Traffic Director sees it and provides access to it. When a virtual machine goes away, it drops it from the load balancing pool and everything is good. So let's do a demo of what that looks like. So I'm opening up a new browser window, and I'm going to connect to sun1.org, the same address I put in DNS. And how it works with a load balancer is every time I fetch that web page, it's directed to a different server in my environment. So if I go back to my Canvas, store is one of many virtual machines that I have here. If I hit refresh on that same web page, it's going to get the same content but from a different server in my environment. So I keep clicking, and every time it comes from a different physical server, virtual machine in my Ravello application. So this is how load balancing works through Oracle Traffic Director, and this is how you provide high availability for your virtual machines as well. So to prove this is real and not make-believe, I'm going to go out on a limb and allow you to send me email to this environment right now. So I've configured two email addresses. One is jdoe@sun1.org. The other is doug@sun1.org. So go ahead and send me email from your desktop right now. And let's see if this actually works. So while you're doing that, I'm going to do the same. Here's my Oracle email. Hopefully there's nothing special in here or embarrassing. I'm going to send one to jdoe. I'll send another one to Doug. Testing. Hello. Oops. And send it. And boom, it's sent. So what I've done to show you what's going on is I have configured another Thunderbird email client that will check the email in these accounts. So here's my email I just sent out. And here they come. Hello. So now I'm proven that this is actual production email that can be handled through Ravello. So don't be afraid and don't think that Ravello is only a cloud-based environment. You use the cloud to deploy production quality applications quickly. You saw, usually when we deploy these things, and if you look at how we're doing the cloud-based version of this, we're spending too much time doing policies and procedures and not getting stuff out. You saw live over this webinar that I was able to build a real cloud environment by dragging and dropping these virtual machines. And before I knew it, I had a production email environment that's actually able to receive and retrieve email from the open internet with a very minimal amount of fuss. So that is it for me for the presentation. I left some good time at the end for some Q&A. So Simon, are we ready to go ahead and start answering some questions?
Yes, there's not, everyone, if you have any questions for Doug, please post them to the chat and then we'll forward it to Doug and then we'll discuss it. So there's one question from Christopher. How did you create the DNS alias for www.sun1.org? It's not clear to me.
Very good question. It's not created in Ravello. So normally when you have a domain that you own, simonlaw.org or .com, you use a DNS provider like GoDaddy or whoever to provide that DNS registration for you. So when you do that, you're given a dashboard that you can add and remove entries from your DNS. So what I did is use that same dashboard in the DNS provider to add an alias. And all I did was add that one entry, www.sun1.org is pointed to that Ravello specific host name. I do that once and then I'm done. I'm able to grow and shrink the environment all day long, and DNS will always point to that Ravello environment through Oracle Traffic Director. So DNS has nice little tips and tricks that make your life a whole lot easier. Now, the Ravello DNS is what you use for internal systems to talk to each other. So if I spawn a new virtual machine, it doesn't have to know how many virtual machines I've added or removed. It just does a DNS lookup, and DNS is always up to date based on the virtual machines I happen to have dragged and dropped into my environment.
Okay, Doug. Follow-up question from Chuck again on DNS name. If you don't have the DNS name, can you just use the IP address, internal address?
Well, no, you don't want to use IP addresses. You want to use the virtual machine name that's assigned by Ravello. Because when Ravello creates a new virtual machine, it will automatically assign an IP address to it. So when I have the components within my environment, when people sent email, the Oracle email server connected to that access layer, those front-end mail systems. And then that system, I had John is on one email message store, Doug was on the other. In order for the front-end servers to figure out where that data lives, it does an LDAP lookup. The LDAP lookup said, hey, Doug's email is on store 1. If I put an IP address in there instead of a host name, if I dragged and dropped those virtual machines in a different order, it's not guaranteed that the IP address that I had before is going to match up the same way. So when you use a DNS instead of these static IP addresses, you no longer have to worry about IP addressing, and it makes life a whole lot easier.
All right, thank you. Can you show how to create a VM using a cloud image?
Yes, and this is tricky. So, and I was planning on doing this anyway, so this is going to be fantastic. So let's go ahead and do that right now. I have all of these different VMs. I'm going to take that empty cloud image. I'm going to drag it and drop it with everything else. And no, I don't. There we go. So now I have this. I'm going to move the chat window out of the way. So I've dragged and dropped it to the canvas, and I need to make a couple changes. The first one is that I need to replace the disk drive, which says replace me, with the cloud image I uploaded. So I'm going to delete the one that comes with it. I'm going to go add disk based on image, and let me get this out of the way. Here's the QCOW I uploaded. Select, boom, now it's here. And I'm going to change it from an emulated disk controller to that cloud optimized disk controller that I can do a direct access to that's a lot faster. It's called Vert.io. The same thing is done already for the NIC. Vert.io is there. The problem with this particular empty cloud image is it has port forwarding enabled. You don't want that. You want the public IP defined instead. So those are the 3 changes you want to make, or the 2 changes you need to make. And then let's do the fun part, which is the cloud-init component. So what I'm going to do is I am going to select my private key, and private keys are defined in the library of your Ravello dashboard. So that's my key. And then I'm going to take that user data script. And I have one already typed out, cat Now, problem you're going to have if you have this PowerPoint deck, as you cut and paste out of the PowerPoint, some special characters come in. Here's cloud config. So if I do set list, see here all these little blue things. Let me make it bigger. This is a space. This character right here is not a space. It's called an NBSP, a non-breakable space, which is not valid in the configuration file. So I'm going to hit replace and then the space bar, R space, R space. Now those special characters are out. So now you know if you cut and paste out of my my presentation, this is an error you're going to run into. So I made the changes. I'm going to cat cloud config, copy and paste this stuff, go back to my dashboard, and paste it right here. So I've taken that cloud image I downloaded off eDelivery. I've disabled SE Linux. I've disabled IP tables because Ravello is going to be the firewall for me. And that secret thing here is replacing system release with the Red Hat release, and that makes everything work great. Change my time zone. I'm going to save it, update my existing application, and boom. This is going to boot. It takes 5 minutes for it to come up and running. And I'm going to come back to this. I'm going to answer some more questions, but I'm going to bring up the console of this virtual machine so you can see cloud-init making the configurations and automating the configuration of your VM to make your life a whole lot easier. So we'll be back in 5 minutes. Let me go back to the chat.
Okay.
But yeah, so that's all it takes. That's pretty easy.
All right, we'll come back to that one. So there's a few more questions. So are all QCloud2 disk image created in OpenStack compatible with Ravello, just like the Oracle Linux 7.3 image that you used?
Yeah, because in OpenStack-based environments, and the thing is that what we're doing here is not OpenStack specific. OpenStack is one framework. Ravello doesn't use OpenStack, but it uses all the same interfaces. That is, the virtualization or the hypervisor is KVM. It uses libvirt for the direct paravirtualized device access. That was that virt.io stuff that I put into the virtual machine. And then it has the cloud-init framework for automating the virtual machine management. So you can do that in OpenStack. Ravello provides the same exact environment. You can do it in Amazon Web Services. You can do it in other cloud-based providers as well. So again, I did not go into the specifics of OpenStack here. I went into the specifics of creating a virtual machine that would run well in OpenStack, leveraging its power, and using that same virtual machine, leveraging Ravello's power at the same way. If I took this disk image and I exported it to an Amazon machine image and imported it into AWS, it would be doing the same exact stuff. So it's a great way to build a virtual machine environment once and to run it in several different cloud-based platforms.
Okay. There's a question from Ian. In CGBU, we have EMS, Element Management System, that use OpenStack to spin up new servers. In these cases, the EMS kicks off the establishment of a new server via OpenStack. Can we do the same in Ravello?
Yeah, so you certainly could run OpenStack as far as the platform on top of Ravello and do it the exact same way. But the way I would do it in Ravello is instead of using OpenStack, Ravello has its own cloud platform. So you would use a Ravello SDK and the command tools to generate instances and remove instances programmatically instead of using the dashboard. Same orchestration end result, just done in different ways.
Okay. Doug, please, can you indicate the format of the disk image we can use to create the image?
Yes, yes. So again, when you download a cloud image from eDelivery, or you can generate your own, the format that's normally used is called QCloud2. There's other formats for storing it, but the way that OpenStack does it and the way that Ravello does it is QCloud2. And the difference between that and like a VMDK or a virtual box a format is that these are meant to be a building block to build a new virtual machine. They're not a virtual machine in and of itself. So that's why in Ravello, I had to take an empty cloud image, take that cloud image QCal file and attach it to that image, and attach it to that VM to help it, and then boot it up. So I can share one cloud image across multiple virtual machines instead of having a single VM and trying to snapshot it and export and import it. You end up in the same place, but the QCal is a more efficient way to build VMs from a base starting point. And the big thing is that the Oracle Linux folks took the time to plug in the cloud-init machinery to make automation possible. And they also configured it to remove all the device naming issues for your Ethernet ports, where it's ETH0, ETH1, instead of the new format that seems to break when you move between virtualization environments.
Okay.
All right. Hey, before I answer another question, that empty cloud image has booted. So if I bring up the console, here you go. So all the stuff at the end is what cloud-init is doing. The first thing is this line right here. I don't know if you can see my pointer. It says new size for this disk. So I can change the size of the disk in Ravello. Cloud-init sees that because Ravello passes that information to it, and it will dynamically change the size of that boot disk based on what you stuck in your dashboard. And then this section down here is where the networking was set up. I make the change in Ravello. Ravello passes it through cloud-init to your OS, and those changes are done dynamically. So I can change things like host names and IP addressing on the fly in Ravello, and the OS, when it boots, will be able to take advantage of that change or see that change and apply it. Then this last session here is taking that key pair that I installed in Ravello and install it in the OS, and then it created a user account that used that SSH key for access. That's that cloud user account I used when I made an SSH connection. Any other questions?
Yes, there's a few more. Let's see. How does the Ravello canvas graphically, I guess, between the dev test and the cloud deployment? I wonder if, Christian, are you asking the same question as Ian? Is it how Doug, how on the canvas have different sections? Doug, can you switch back to the canvas?
Yeah, get rid of this.
Yeah, Christian, are you asking whether the different tiers, because what Ian asked about how you do these color boxes, and then Christian's asking how does the Ravello canvas graphically between dev test and cloud deployment? But maybe you can answer Ian's question first.
The box, what you see here in the canvas is for your benefit. So these groupings of virtual machines, you add those by clicking the group button. So I click the group button, I drag and drop it to the canvas, and then I can drag and drop cloud virtual machines into it. And that's really for visual sake. Ravello doesn't really do much with it other than present it that way on the canvas. The other thing are making connections. So in the case of this virtual machine, it provides services like mail, web access, SSH. The dot here means that they're externally accessible. And then on the right side, these are required services. So in order for an email server to work, it needs an LDAP server. So my LDAP server is running over here, and Ravello makes connections between required services and supplied services so you can see how these components interact. Again, all this is for your benefit when you see the canvas, but as far as changing how the virtual machines behave, no. All these systems can talk to each other because they're on the same physical network within your Ravello application. Hopefully that answered the question.
All right, thank you. A question about Doug. Did you actually import any virtual boxes into Ravello, or do you always create from scratch?
Yeah. No. So when I first started with Ravello, I have a whole set of VirtualBox. I came from Sun, so VirtualBox is my friend, and VMware images on my ESX server that I would export and import using the VM import tool for Ravello. But as you saw in previous sessions of this call, I always ran into issues. Like, for example, my VMware virtual machine would take the MAC address of the virtual network adapter and put it in the configuration of the OS. So when I moved that virtual machine disk image to Ravello, the MAC address for that physical or that virtualized physical network adapter was different. So the boot or the network stack failed to come up because of that. So, you can certainly start with a virtual machine that you created somewhere else and to get yourself up and running and make changes and configure, add cloud-init and other things, and then export that as a QCal image. And there's a knowledge base or article on the Ravello site that shows you how to do that. But again, going back to the very first slide in this presentation, there it is. I can certainly import existing VMs, but you bring issues from that existing VM to your cloud-based environment. So my goal is to do it differently, where you start with a fresh VM that leverages the cloud framework, and you deploy your application there. Once you've had it built cloud native, then you share the cloud image with your friends and colleagues and move it to different cloud-based providers as well.
I see.
So one thing I'll do is I'll start with the cloud image from eDelivery, and I'll boot it up, use that cloud-init to get it set up initially. I'll go ahead and install my application and get everything the way I want it. And then I go back to Ravello and I save it to the library. So if I take this guy and I go save to library, and it's running, so it's not going to go very far. But once I save it to library, that image, that virtual machine is already set up the way I like it. If I take that virtual machine and drag it back into the canvas, I'm able to customize it from that point forward. So I don't have to repeat all the changes that I made initially as far as, that system release file and disabling IP cables. That's already been done in that particular virtual machine. So what I do, and you'll see in my VM library, I have something called base, and that's an already configured OS. So I've done all the changes I've needed to, and I've saved that. Now when I want to deploy a new application, I start from that starting point, install and configure the application, and then I save that to the library. So what you saw here, me dragging and dropping, is that I have a single virtual machine image that runs all of this stuff. I installed it once, and then using cloud-init, I look at the host name that Ravello gives me, and I configure myself on that first boot based on that. So I can make a VM once, and I can use it for different things. So the way that a web tier server is configured is different than the way a data store server is configured. So let me show you how that works. Here is one of those boxes. I have, here's some things I do to change my configuration. For example, when I brought up the web browser, this thing here, where I was using the load balancer to get access to it, how I changed that is I went into the index.html of the mail server, and I ran sed that took the word running and replaced it with the host name of that particular box. So that is run only on the first boot, but it worked out great for my demo because now when I refresh the page, before it just said your server is now running. I did a search and replace and put the host name there, and that's why I can tell where that host is coming from. So there's lots of little tips and tricks you can use to make your life a whole lot easier in a Ravello environment, where you do it once, you never have to do it again, and you can have a common building block that you can use in a number of different areas. The difference and the secret is that you build your VMs in a way where you build for the things you need once, and then you save the particular host-specific things that you need to change, and you have the cloud framework do that for you through cloud-init. One virtual machine, drag and drop, and then cloud-init says, hey, your role in my environment is this. And what we use in our environment for UCS is we have a recipe language where I can run a recipe that says, I am a message transfer agent. And based on that, I'm going to make these configuration changes. So that's automatic. What you'll see in a lot of cloud environments is they'll use the same concept using something like Chef or Puppet. And how Chef and Puppet work is they're the same way. I can take an existing virtual machine and I can automate the specific configuration changes for my application to match up with the virtual machine that I want to deploy.
All right. Thank you very much, Doug. This is an excellent session. Unfortunately, we run out of time, so we're going to end it here. If you still have additional questions, you can post them onto the community forum on the discussion forum. And again, thank you very much for joining, and thank you very much, Doug. We'll see you all next week.
My pleasure.
Yeah.